To simplify radicals by reducing the radicand, we break down the number inside the radical into factors and simplify any perfect square or perfect cube values within it. A radical becomes simpler when we remove these perfect powers from inside the symbol. For square roots, we look for perfect squares such as 4, 9, 16, 25, and so on, because these have whole number square roots. For cube roots, we look for perfect cubes like 8, 27, 64, and 125. Once the radicand is factored, we take out any perfect square or perfect cube and rewrite the expression with the simplified value outside the radical. Any remaining factors that do not form a perfect square or cube stays inside. This process often involves prime factorization, where repeated factors are grouped, pairs for square roots and triples for cube roots. By identifying these groups, we can pull out one copy of the number for each pair or triple we form. In the end, simplifying radicals means rewriting the expression so that no perfect powers remain inside the radical, resulting in a cleaner and more efficient form.
Let us try to simplify. Example number 1. What is the square root of 48? Step 1. Think of the highest factor of 48 that is a perfect square, and that is 16 and 13. Step 2. Simplify. The square root of 16 is 4. However, 3 is not a perfect square, so we put 3 inside the radical sign and the 4 outside since 16 is a perfect square. So the final answer is 4 square root of 3.
Example number 2. Square root of 72. Step 1. Think of the highest factor of 72 that is perfect square, and that is 36 and 2. Step 2. Simplify. The square root of 36 is 6. However, 2 is not perfect square, so we put it inside the radical sign and 6 outside since 36 is a perfect square. So, the final answer is 6 square root of 2. Example number 3. We have cube root of 81. Step 1. Think of a highest factor of 81 that is perfect cube, and we have 27 and 3. Step 2. Simplify. The cube root of 27 is 3, so put that outside the radical sign. And since 3 is not perfect cube, we keep it inside the radical sign.
Example 4. We have the square root of a raised to 8, x raised to 12, and y raised to 4. Step 1. We divide the exponents to the index. In our example, it is a square root. So, we divide 8 by 2 and the answer will be a raised to 4. 12 divided by 2 is 6. That will give us x raised to 6. And 4 divided by 2 will be equal to y squared. So, the final answer for our equation is a raised to 4, x raised to 6, and y squared. Example 5. We have the square root of a raised to 5 and b raised to 10. The first step is we divide the exponents by the index. Since 5 is not divisible by 2, the remainder will be placed inside the radical sign. For this case, how many groups of 2 can you make from 5 without going over? And that will be 2 groups, which is equal to 4 with 1 left over. You will get a raised to 4, and since 10 is divisible by 2, so we just copy that. Step 2, we simplify. We divide 4 by 2, which is equal to a squared, and 10 divided by 2 will be b raised to 5. So the final answer will be a squared, b raised to 5 square root of a.
Example 6. We have square root of 75x raised to 6. Step 1. Identify the highest factor of 75 that is perfect square. That is 25 and 3. Step 2. Simplify. The square root of 25 is 5. 3 is not a perfect square, so that will be in the inside of radical sign. And for x raised to 6, 6 divided by 2 is 3. The final answer is 5x cubed square root of 3.
Example 7. We have the square root of 48x cubed and y raised to 6. Step 1. Find a factor of 48 that is a perfect square and that is 16 and 3. Step 2. Simplify the square root of 16 and it is 4. Since 3 is not divisible by 2, only one group of 2 can be made out of 3, and 6 divided by 2 is equal to 3. So put all perfect squares outside the radical sign, and the final answer will be 4xy cubed, square root of 3x.
To simplify the square root of 200x cubed, we look for a perfect square factor inside the radicand because only perfect squares can be taken out of a square root. First, we factor 200 into 100 times 2, choosing 100 because it is a perfect square. Then we factor the variable expression x squared into x squared times x, where x squared is also a perfect square. This lets us rewrite the expression as the square root of 100 times x squared times 2x. Next, we separate the radical into the square root of 100, the square root of x squared, and the square root of 2x, using the property that the square root of a product is the product of the square roots. We can simplify the square root of 100 to 10 and the square root of x squared to x, while the remaining 2x stays inside the root because neither 2 nor x is a perfect square factor. Combining the simplified parts, we get the final answer 10x, the square root of 2x. To simplify the square root of 108y raised to 5, we again break the radicand into perfect square factors. The number 108 can be factored as 36 times 3, with 36 chosen because it is a perfect square. For the variable part, y raised to 5, we separate it into y raised to 4 times y, allowing y raised to 4 to be taken out of the square root. This transforms the radical into the square root of 36 times y raised to 4 times 3y. The expressions square root of 36 and the square root of y raised to 4 simplify to 6 and y squared respectively, since both 36 and y raised to 4 are perfect squares. The remaining factor, the square root of 3y, is left as is because it contains no perfect square factors. Putting everything together, the expression becomes 6y squared, square root of 3y.